Good morning, my dear students. We're back with class 11 session. Today is actually not my class, but I just thought that it would be good if I add up some more topics to your study lessons. Last time we have seen the equation for work done during expansion of a gas, and the work done during expansion of a gas, it was given by work is equal to integration of P dV from V1 up to V2. This is the equation we have got last time. And even we have derived the equation for work done during isothermal process. So in that case, let me just highlight that one more time. The equation was integration of PV is equal to RT. In that case, this was taken as constant. So P is equal to constant K by V. So it was put here. So K by V dV from V1 up to V2. So when you take it outside integration, K 1 by V dV from V1 to V2. And it was equal to K log of V. Then you have V1 and V2. So this was equal to K again log of V2 minus V1 here after putting upper limit minus lower limit. Okay, then so equal to log of V2 by V1. This was the equation. And the natural logarithm log E, it was equal to 2.303 log of 10 here. So after using this value, you have work is equal to K 2.303 log of 10 V2 by V1. And as we know, K is equal to RT. K is going to be RT. So we can write RT 2.303 log 10 of V2 by V1. This much we have done in the derivation in the previous class I meant. So this is the equation for work done during isothermal expansion. Okay. Then before I continue for derivation of work done during adiabatic process, we need to remember our first law of thermodynamics here. That is, let me write again, first law of thermodynamics. In that case, delta Q is equal to delta U plus delta W. This was the equation, where delta Q is the increase in energy. This was especially the heat energy you supply to the gas. Suppose that this is the gas. You supply heat delta Q. After supplying heat, internal energy increases. Then the gas start performing work here. So this is the increase in the energy, or just like adding energy, you can say. Adding energy. This is the increase in internal energy, and this is the work done here. So in today's class, I am going to discuss briefly the application of this first law of thermodynamics here. So topic should be applications of first law of thermodynamics. So our equation is delta Q is equal to delta U plus delta W. So now we'll apply it to the first isothermal process. We know that in isothermal process, temperature is constant. The temperature being constant in isothermal process, If temperature is constant, if T is equal to constant, means that temperature is not rising or not decreasing, then internal energy change in internal energy delta U will be 0 here. There will be no more change in the internal energy. It means that temperature constant means no more change in the internal energy. Keep in mind this. Therefore, your delta Q is going to be equal to delta W here. That is amount of heat added. Amount of heat added to the gas. This is simply equal to work done. And since the work done is positive, the work is done by the system here. So you can write work done, or say work is done by the system. Now I know you are a bit confusing about this. In the sign convention, okay, what happens is, if work done is positive, then this is taken as work is done by the system. Example, say you have a cylinder here. Here is a gas. The gas is expanding now. If the gas is expanding, work is positive. It means the gas is doing work here. So whenever you see work done, and if it is positive, keep in mind that work is done by the gas, not on the gas. So if the work done is found to be negative, so this is taken as work is done on the system. Suppose this is the gas again. You compress the gas, keep on compressing. If you compress the gas, work is going to be negative here. So it means that work is done on the gas. Gas is the system. Okay, this is the sign convention we take it. So now coming back to our equation, delta Q is equal to delta U plus delta W. In the isothermal process, delta U is equal to 0. Therefore, delta Q is equal to plus delta W. It means the amount of heat added, this is equal to work done by the system here. This is the meaning. So now let us apply it to the second one here, isochoric process. And you know, in isochoric process, the volume is going to be constant. A thermodynamic process that takes place at constant volume is known as isochoric process. So if the volume is constant, like volume is not changing, initial also 5 for example, final also 5 for example, no change in the volume. So change in volume, this is taken as 0. It means that is what, there is no change in the volume here. Okay, so if volume remains the same, means volume is constant, at that time delta V is going to be 0. It means there is no change in the volume. Therefore you apply now delta Q is equal to delta U plus this delta W can be written as P delta V. Go back to our class again. The earlier classes you have seen this one, work done, small work done is equal to P dV. We have already seen the derivation before. So this work done, change in the work done here, or this work done, we can write as P delta V. But you know, in isochoric process, delta V is equal to 0. Therefore you can write delta Q is equal to delta U plus 0 here. Why? Since delta V is equal to 0. So finally you have delta Q is equal to delta U, that is heat added to the system is simply equal to increase in internal energy. Okay, it can be asked to prove this one. And one more reminder is that in the case of internal energy of a gas, this delta U for the change in internal energy, delta U stands for change in internal energy. So this part, or simply increasing the internal energy, will be simply equal to sum of kinetic energy of molecules and potential energy of molecules here. It means you have a gas. If you are going to find the internal energy will be Ke plus Pe. Kinetic energy for whom? Kinetic energy of the gas molecules. Potential energy of the gas molecules. When you find the sum, you get the internal energy here. And this kinetic energy of the gas molecule, kinetic energy of gas molecule will be depending on temperature. It means if temperature rises, kinetic energy also increases here. I repeat again, if temperature is increasing, kinetic energy of gas molecule increases. So if kinetic energy increases, internal energy also increases. Okay? It means if temperature of gas increases, Ke also increases, and hence if Ke increases, internal energy will increase, and hence internal energy will increase. So delta U is going to be what? Positive here. Increase in internal energy is what denoted by delta U, and if it is positive, it means that it is rising, increasing here. So just go through these important terms one more time, and in the next class we'll try to derive the equation for work done during adiabatic process.